Here we are for the first video of section 2.6, and actually we're going to separate this up into two different groups, so we only have to worry about the first half this week, and we will look at the second half later on. And so here we go. We begin with what appears to be review from previous sections, in that if we're given a function with a graph, we need to determine the limit if it actually exists. And number one, we're asked, what is the limit as x approaches 2 from the negative side, or actually from the left side of that particular graph? Well, right at 2, it has many different values. It appears to be either going to 1 or to 4, or actually having the value of -1. But we're asking, what's the limit coming from the left? Well, it appears like it is going down to the value of 1. So the answer for number 1 is 1. Now number 2, it seems like we have seen this particular graph several times in this course, but we're asking, what is the limit as x approaches 0? No sides, just the actual limit. And both direct. Remember that in order for the limit to exist, it does need to come to the same place from both directions, and it does appear to be going to the value of 0. When x equals 0, it certainly looks like it's going to the y value of 0. Now, the big point of this particular section are limits dealing with infinity. And there's two ways to look at it. We can either have x approaching either positive or negative infinity, as well as our limits may actually be infinity themselves. So let's look at number 3. Number 3 is asking, what is the limit as x approaches negative infinity of -7 plus 7 over x all over 6 minus 1 over x squared. Now here's a dirty little secret, I guess you could call it, in math. Up until now, whenever we've had 1 over 0, we've said that's undefined. Well, actually, if we think about it, if we take 1 over a very small number, we get very large numbers. And so 1 over 0, we're now going to consider to be infinity. Of course, if it's really close to 0 on the positive side, it would be positive infinity, and if it's real close to 0 on the negative side, it would be negative infinity. So realize when we get to that, that will make our lives quite a bit easier. Likewise, we can actually put infinity, as we're trying to do here, into an equation. What this becomes is something similar to this: -7 plus 7 over infinity, actually 7 over negative infinity. And this down here would become 6 minus 1 over, well, negative infinity, the quantity squared, becomes a positive infinity. And so we look at, what is anything, in particular 7 over infinity, equal to? Well, 7 over a very, very, very small number, negative 999999999, this in essence becomes 0. And that's what we're going to do here. We're just going to say that is so close to 0, that's where its limit is going towards. Likewise, 1 over a very large number is still 0 also, so it will be 6 minus 0 as well. And so this ends up equaling -7/6, which is the limit for number 3. Number 4, we're going to use the same reasoning on this problem. 2x cubed, except we have to do something just slightly different here. Okay, now here, intuitively, what we're going to look at is this. If we look at just the numerator, which of these is really causing the biggest behavior change? And basically, another way to ask that question is, what is making it grow the fastest? And that would be just this term here. So in essence, this term here really doesn't mean a whole lot in this term doesn't really mean a lot either. But be careful, don't just completely eliminate those, just realize this is the thing that really tells us what's going on. Likewise down here, which one is going to be the bully? Which one's going to cause the most change? Once again, it's the x cubed. And so this, in essence, is going to make very little difference. And so let's see what we end up with here. So this becomes the limit as x approaches infinity of the important parts, 2x cubed over negative x cubed. And notice what happens there. We can cross those out, which leaves the limit as x approaches infinity of negative 2. But what is the limit as x approaches anything of a constant? It's that constant. And so the limit here would be negative 2. And all we're doing here is, since we're talking infinity as x approaches infinity, we can consider it this way. Which one affects it the most? Well, in this case, this one and this one. Likewise, we could have used that same argument up here. This 7 over x doesn't affect it as much. What's the bully up here? It's this negative 7. Likewise, here, the 1 over x squared doesn't change it a whole lot when x is very, very small. So 6 is the bully. And so we can ignore those, and that just leaves negative 7/6. And the next group, it says divide the numerator and denominator by the highest power of x in the denominator to find the limit. This is a trick that we can use, which really justifies the whole thing. Ignore everything else but the bully. You know, it's the bully that controls everything. Whereas this is the mathematical reasoning behind it, I guess, is the best way to explain it. So let's look at what this is intended to mean or show. Suppose we have the limit as x approaches infinity of negative 4 square root of x plus x to the negative 1. So let's just do 1 over x all over negative 3x minus 3. And we are told to divide both the numerator and the denominator by the highest power of x. Well, the highest in the denominator. Well, the highest power of x in the denominator is x. But remember, if we're going to have to multiply the numerator by 1 over x, and we're going to have to multiply the denominator by 1 over x. Or 1 over x is 1 over x. Multiplying by 1 over x is the same as dividing by x. And so let's see what we get. Now here's where we need to do a little bit of algebra thinking, I guess is the best way to show it. And that is, when we multiply this by 1 over x, we actually need to put this 1 over x in the radical. And that's where, when we multiply by 1 over x, it's not simply the square root of x over x. Instead, once we put it under the radical, we actually have to square both the 1 and the x. So it becomes 1 squared over x squared, or 1 over x squared. So that, what happens there is it becomes negative 4 times the square root of x over x squared plus 1 over x times 1 over x is 1 over x squared, all over negative 3x times 1x is negative 3, and 3 times 1 over x is 3 over x. Well, the nice thing about it is, since all of these x's are in the denominators, and x is approaching infinity, these are going to be going to 0 like crazy. And so what we get is a situation like this. We get negative 4 times 0 plus 0 all over negative 3 minus 0. Well, negative 4 times 0 plus 0 is 0, and negative 3 minus 0 is negative 3, and 0 over negative 3 is the boring answer of 0, which is perfectly okay. But realize that if you're in doubt with your algebra, you can always graph this and look way to the right. In this case, we're going to look way to where x, might be 100 or 1,000 or something like that, and see, is it getting closer and closer and closer to 0? And if it is, then we can probably assume our algebra was correct. However, you do need to have some justification. You can't just say, well, I'm going to graph it and then look at it. You need to know how to manipulate it in this way. Okay. Number 6. The limit as t approaches infinity of the square root of 4t squared minus 8 all over t minus 2. And we are still in the same directions. Divide the numerator and denominator by the highest power of x in the denominator. Well, the highest power of t is t. So we're going to multiply by 1 over t over 1 over t. And let's see what we get. Once again, for the same reason, we're going to bring it under the square root. So this is, when we bring it under the square root, it's actually going to be 1 over t squared. So we get the limit as t approaches infinity of 4t squared over t squared is 4 minus 8 over t squared all over t times 1 over t is 1 minus 2 over t. And since t is going to infinity, now those become a lot of zeros. So we get the square root of 4 minus 0 over 1 minus 0. Square root of 4 over 1, which equals 2 over 1, which equals 2. Once again, if you graph this, it becomes very, very important. It just proves the point that it just seems to get closer and closer to the value of 2.